Let's continue interpreting the DF data frame. Which column do we have next? Reason for absence. We'll need to find out a way to extract this column only from our data set. Probably, the best way to do this is by typing the data frame name, and then, within brackets, indicating the name of the column you would like to examine in more detail. In our case, this will be the reason for absence column. Execute, and that's exactly what you see, right? We must clarify that on the left, we have indexes designating the order in which the elements appear, starting from 0 naturally. And then we got the exact values we needed. Okay? Let's perform a check. Here, we begin with 26, 0, and 23. In DF, reason for absence starts with 26, 0, and 23 too. You can check all remaining 697 values if you wish, but I am confident we have retrieved the correct information. You may be wondering which the lowest and highest values are stored in this column. The min and the max methods can provide us with the answer. After we apply these, we obtain 0 and 28 respectively. Okay. Now, instead of obtaining all 700 observations with the reasons between 0 and 28 being repeated, we want to extract a list containing distinct values only. In other words, we want to see all the different values organized in a list and only shown once. To do this, you can call or invoke the unique method from Pandas here, PD, with an argument of DF reason for absence. And you'll obtain the required result. The second way to call the same method and extract identical output is by ending the DF reason for absence expression with .unique open and close parentheses. You see? Great! Moreover, the output will often tell you what kind of values you have in that column. D-type integer 64 means that here they are all of the following type, 64-bit integers. Awesome! What else might you like to do? Perhaps see how many distinct elements are in this column? Sure, why not? To do this, you can use the built-in len function, whose name comes from the word length. When you use the same expression from the last cell as an argument of the len function here, what you get is the number 28 precisely. Hence, we can conclude the column of interest contains 28 different reasons for absence from work. However, wait, didn't we already find out that minimum value contained in this column is 0, while the largest one is 28? This makes up to 29 different values. While using the len function, instead, we just obtain 28. This has to say one thing and one thing only. A number between 0 and 28 is missing. Which is it? It'd be hard to read all these numbers from here and suddenly discover the missing number. We'll probably need to take a pen and paper and write them down in the correct order to figure that out. Fortunately, there is a way to do the same thing in Python. The built-in sorted function returns a new sorted list from the items in its argument. That's why sorted, open parenthesis, the expression delivering the list with unique values, close parentheses, will deliver a list with all numbers from 0 to 28, with one exception, the missing number. As you scroll from top to bottom within the output here, you can spot that the value we lack is number 20. Hence, here we have all but one of the numbers from 0 to 28. Okay. All Python tools we used so far while working on the reason for absence column were meant to show you what kind of intuition you need when digging deeper into data preprocessing and analytics. Therefore, if you have the eyes of a hawk, data preprocessing is a field where you can definitely take significant advantage of that. Attention to detail induces you to perform checks that will only solidify the inferences made throughout your analysis later. fantastic. This will do for now. Thank you for watching.